Welcome back to part 2 of this probability video. If you haven't checked out the first one, go back and check it out. It is called What is Probability? This is the second version of it, or the second video to the mini series, you can say. We just got done talking about flipping a coin and how to represent the answer. All of these are appropriate answers for the question of the probability of flipping heads. And so I would take any of these three solutions. Now, if we take this concept and we go and we take a look at our actual problem that we have up here, there's a couple things that I want to talk about before we get to the point we're ready to answer. Number one, sometimes you'll see an image that looks like this. Sometimes it's a square, it could be a triangle, a circle, anything that has partitions in it or different sections of it will be known for us in the future as the area model. The area model is a tool to solve probability problems. Now, you'll see that the area model is actually derived because here is each color takes up a specific area, and we can actually see that each row and column, when we put them together, creates this big area here of the square. Now, these colors are the partitions. Sometimes they could be various shapes, they could be symbols, it could just be two different shades of colors, it could be just black and white. Different images may have a different way of expressing an area model. An area model is one of three tools. I'm going to put over here one of three tools that I want to introduce to you over the next couple of days, next couple of weeks, so that way you'll have the opportunity to make use of them as you go to solve some of these problems. So, transitioning over, if we use this area model to help us find the probability of hitting green or blue or red or yellow, the first thing you always want to do is see the total number of squares. So if we come over here and we take a look at our notes on the right side, you'll see that if we're setting up a fraction, we want to discover what's the total number of options or the total number of things that we're trying to find the probability of, and we want that to be in the bottom of the decimal. So for all of these cases, if we look and we count up all the squares, we'll see that it's a 6 by 6 square, which means there's 36 possible tiles or spaces here in this area model. So if that's going to be the case for all of these, then we can just go ahead and put 36 at the bottom of each fraction. Then it becomes easy for us to go back and find the number of things we want, or the number of occurrences for each of the events located within this probability model. So when we look at green, we count them up. 1, 2, I'll put little x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we get 12 out of 36. Turns out the same thing happens with blue. We'll count them all up. You'll get 12. When we look at the reds, we actually get 8. There's 2 on each corner. We have 1, 2, 3, 4, 5, 6, 7, 8. And then finally, yellow, we just have the 4 in the middle. 1, 2, 3, 4. When we go to find the probability of something like this, and we'll talk about this as we continue forward within the unit, we know that we've calculated all possible scenarios if the sum of the probabilities equals to 1, or 100% of the possible options. In this case, if we add them all up, it does equal 36. Those are all the possible options. Which one's most likely? It's actually a tie between green and blue. If you take a look, they have the exact same probability. Hope this helps. I'll see you in class next time. We're going to be using the area model to help us look at a different problem as we get back together during our class session. I'll see you next time.